This is R.D. Sharma Solution Class 12 Chapter 7 Adjoint and Inverse of a Matrix. Exercise is 7.1. In order to have an idea about adjoint and inverse, the precursor is you need to know the determinant of A, how to find out the determinant of A and the matrix multiplication. This is the first question, find the adjoint of the following matrix. And there are questions which will be coming, those are just the repetition, same type. So please understand it very well. This is 2 by 2 matrix. So when you have a 2 by 2 matrix and this is a square matrix means row is equal to column. There are 2 rows and there are 2 columns. So this is 2 by 2 row and column equal matrix. So when we are in a process of finding adjoint A, 2 by 2 is very simple. We have -3, 5, 2 and 4. How to do this? It's just interchanging like this. See. So we have to exchange 4 and -3. So just put it here. 4 here and -3 here. So exchanging the diagonal element. And what about the 5 and 2? This is your A. This is your adjoint A. So this 5 and 2, what you have to do is, you have to change the sign. So 4 and -3 has been exchanged and 5 and 2 negative sign. So there are 3 things which we need to verify. Adjoint A we have already found out, A already found out, so you can do always the multiplication. So I told you, you need to know the matrix multiplication. I'll do one of it. So 4 minus 5 minus 2 minus 3. And this is going to be adjoint A, and I am multiplying adjoint A with A. This is adjoint A. And what is our original matrix? We are doing the first one, right? So this is -3 and we have 5 and 2 and 4. Okay. 4 into -3 minus 12, minus 5 into -2 minus 10. 4 into 5 is 20 minus this -5 into 4 is -20. Then -2 into -3 is 6. And -3 into 2 is -6. -2 into 5 is -10. -3 into 4 is -12. So what it is going to be? This is -22. And this is going to be 0. This is 0. This is -22. So this is what you got. So adjoint A multiplied by A is this matrix. Similarly, way we have to find out the determinant of A into I and A into adjoint of A. So determinant of A you need to know, means this is a precursor. So this is adjoint A. Let me just show you adjoint this determinant of A, because 2 by 2 determinant is not that hard. So 4 into -3 minus 5 into 2. So 4, this is A, okay? 4 into -3 minus 12. 5 to 2 is 10. So this is -10. So we have -22 as the determinant of A. Now multiply it by identity matrix. 2 by 2 identity matrix I am writing. Now this is a scalar multiplication. Take -22 inside, multiply with every element. You get this same as the previous one. So these two we have equated. I hope you got the idea. And the second one is just, you need to interchange adjoint A and A. That is, first write A, -3, 2, 5 and 4. And you multiply it with adjoint A. Adjoint A was 4 minus 5 minus 2 minus 3. And when you multiply it, -3 into 4 is -12. 5 into -2 is -10. And -3 into -5 is 15. And 15 plus, actually it will be plus, but 5 into -3 is -15. So I'm taking the first row and the first row of the first matrix and the second column of the second matrix, and I'm multiplying each corresponding element and then adding. So -3 into -5 is 15 and 5 3 is a 15, -15. So this is what you got. So you have this, you can write it like this only. So basically what I'm trying to suggest here is you are going to get a 0. So 15 minus 15 is 0. Now 4 to the 8 and minus 4 to the 8. Now minus 10 here. 4 3 is a 12 minus 12. So what did you get finally? This is minus 22. This is 0. This is 0. This is minus 22. The third also has come as the same one. So we have verified. We have verified all of these three. Now this question which we just did, all of the questions which are coming, they are just the repetition. So I'll just give you an idea here. This is A, B, C, D, and previously we have already done a example with actual values. So this is a generalization, and that was actually the implementation. So I'm taking the adjoint. So A and D I'm interchanging, and C and B negative sign. So all these you are able to do. Adjoint A I have found out and told you. Now you can do this. Same here. Same thing here, but since we have sine and cos, I'll try to do one of it. Because adjoint A, let us find out adjoint A is what? Cos alpha you need to interchange, and that doesn't bother because they both are cos alpha. And change the sign of sin alpha. So minus sin alpha here. Okay. Now everything you will be able to do. I'm just going to do the one of it. Say let us do A into adjoint A, because adjoint A into A you can do determinant of A into I, you can do A into adjoint A, you can do. So I'll take one of it and I'll give you what you have to get for all of it. So cos alpha, sin alpha, cos alpha. This is A, and I'm just using a shorthand. Adjoint A, let's write cos alpha minus sin alpha, and here minus sin alpha and cos alpha. Okay. Multiply cos alpha is cos square alpha. This is minus sin square alpha. Then we have cos alpha minus sin alpha is minus sin alpha cos alpha. And then we have sin alpha cos alpha plus sin alpha cos alpha. Okay. Now second row, first column, sin alpha cos alpha and minus sin alpha cos alpha minus sin alpha cos alpha. Okay. And then we have second row with the second column. So minus sin square alpha and minus plus cos square alpha. Okay, this is 0, this is 0. This is cos square alpha minus sin square alpha. So c square minus s square I am writing 0, 0, cos square minus sin square. Okay. So these all you can do, because this is just the question repetition which we did, and as I mentioned you, determinant of A you need to know, and matrix multiplication also you need to know. Otherwise you have to go back and try to see the previous exercises. Here we have same thing here, 2 by 2 matrix. Okay, there is no difference. So adjoint A is quite simple. Let's do this middle one now. Okay, determinant of A also we'll find out, and multiply with the identity matrix that we are going to do. So this is, let's see the adjoint also. Adjoint A is simply you need to exchange the diagonal element 1 1, and then you have to change the sign of the other element. So you just interchange 1 1, so it won't change anything, but this sign you have to change. Tan alpha by 2, here negative tan alpha by 2 minus tan alpha by 2. Okay, now this we are doing. So we'll try to find out the determinant. So I am taking the determinant. It will be 1, means this 1 into 1 is 1, minus tan alpha by 2, tan alpha by 2, tan square alpha by 2. Since it is negative, it will be 1 plus tan square alpha by 2. So tan square alpha by 2. Okay. And this is determinant of A, and multiply it with the identity matrix. 2 by 2 identity matrix is what? 1 0 0 1. The final will be multiply each element inside with 1 plus 10 square alpha by 2. 1 plus 10 square alpha by 2, 0 1 0 0 1 plus 10 square alpha by 2. This is what we are going to get from adjoint A into A also, and A into adjoint A also. So this is going to come for all of it, all the 3 1. Okay. Now compute the adjoint of the matrix, and we have already seen the 2 by 2. This is a 3 by 3, and we have to verify also. So we have to find out the cofactors, and then, because cofactor is important, because we need to find out the cofactor matrix, and then we'll take the transpose, and that transpose of a cofactor matrix is the adjoint A. So let us see this. Let me write it here. 1 2 2, 2 1 2, 1 2, and 2 2 1. So this is here. Now let me equate it. Because if you equate, or you can write it somewhere, then that the computation will be quite easy. There are 3 rows, 3 columns. So let us identify it or indicate it using A11. So I'm not writing A11, but basically C11, because we are going to find out the cofactor. C11, C12, C21, C22, C23, C31, C32, C33. Now why I have written this? Because when we are trying to find out the cofactor, that is C11, cofactor 11, so minus 1 to the power I plus j, I is 1, j is 1. Because in cofactors sign will come. Minors with sign is cofactor. So this row and column you have to leave for C11. So C22, C23, C32, C33 you have to write. So it is 1, 2 and 2 and 1. Okay. So what is the value here? 1 minus 1 to the power 1 plus 1. Please remember minus 1 to the power even will always be 1. Minus 1 to the power odd will always be negative 1. Okay. Minus 1 to the power 1 plus 1. It is going to be plus 1. So the internal one is 1 minus 2 to the 4. So it is going to be negative 3. Let us take one more of it. C11 we have found out. Let us take any cofactor with a negative sign. How? We'll take C32. So C32 is what? It is C32, and this is going to be minus 1 to the power 3 plus 2, and row and column intersecting at C32 will be left, and remaining will write 1 to 2 2. So minus 1 to the power 3 plus 2, that because it is odd, minus 1 to, it will be negative 1. This is going to be 2 minus 2 to the 4. So it will be negative 2. Negative will become positive, so it is going to be 2. So you have to do it for each and every element, right? So each and every element you have to do. I have given you an idea for 2 elements, C11 and C32, but you have to find out, because there are 7 more, 9 values will come. Now I hope you will be able to do it. Now adjoint A is the cofactor matrix transpose. So I am writing the cofactor. So this is the cofactors. All the cofactors I am writing. Now, in order to find out the adjoint A, we will take the transpose of this matrix. We already got the cofactor matrix, which I suggested you. We will take the transpose of this. Transpose of this means row and column you have to transpose. Row you have to make column, column you have to make row. And that is going to be your adjoint A. I'll just show you here. This minus 3, 2, 2 row will become the column. 2 minus 3, 2 is going to become a column. 2 minus 3, 2. 2, 2 minus 3, this row is going to become a column. 2, 2 minus 3. So this one is your adjoint A. Now adjoint A multiplied by A into adjoint A, and determinant of A into I. That you have to do. So all of this you have to do. As I said, matrix multiplication and determinant, how to find out that you need to be very careful and need to know that. Then only you'll be able to understand. So we can take any of this. So this A into adjoint A into A, this is some simply multiplication of these two. One matrix is already given, second matrix we found out. Adjoint A we have found out and A is already there. So it's just a multiplication. Okay. Now adjoint A into A we are doing. So adjoint A I'm writing first. This is adjoint A, I'm just writing here, and we are multiplying it with A. I'm going to show you how actually it will be done. Those who know the multiplication, they can just proceed. So I'll just show you the first column, what will come, because we are short of space. So minus 3 into 1 plus 2 into 2 plus 2 into 2. So minus 3 into 1 is minus 3, 2 into 2 is 4, and 2 into 2 is 4. So 4 plus 4, 8, minus 3 is 5 here. So as I said, just let us do the column only. Others you will be able to do. So I'm taking the second row and the first column. 2 into 1, 2. Minus 3 into 2, minus 6. 2 into 2, 4. So 4 minus 6 plus 2. That is going to be 0 actually. Now third row and first column. 2 into 2, 1. 2 into 2, 4. And minus 3 into 2 is 6. Now this, whatever you will get, I hope you will be able to do it. I'll show you the only first column. It is going to be 5. This is going to be 0. This is going to be 0 again. And rest I'm just writing 0, 0. And this is the diagonal will be 5, others will be 0. So it's basically a scalar matrix with 5 at one's place. Now determinant A, so we can find out the determinant also. First I have already done adjoint A into A, and then determinant of A we'll find out. We'll open it using the first row. So 1 into something, that is the minor will come here, minus 2 into, well, you already have a cofactor, so you can directly use it. C11 plus C12 plus C13, right? C1 means 1 into C11 plus 2 into C12 and plus 2 into C13. That you have to do. But I am just opening it in a normal way. First row, and I am writing the minors inside. So 1 into 1 minus 2 to the 4. So 1 minus 4 is minus 3. This is cofactor also, minus 3 you see. Minus 2 and then 2 minus 4. So minus 2 it will be. Plus 2, 2 to the 4 minus 2. 4 minus 2 is 2. So minus 3 plus 2 to the 4 plus 2 to the 4. So 8 minus 3 is 5. The determinant is 5. Now multiply it with the identity matrix. What is the identity matrix? 3 by 3 identity matrix. 1 0 0 0 1 0 0 0 1. So this is the identity matrix. So this is 5 into I, which is actually multiplication of 5 with this identity element. It is going to give you 5 0 0 0 5 0 and 0 0 5, which is actually equal to what we just got when we actually multiplied adjoint A into A. A into adjoint A, I hope you'll be able to do.